Okay, so in this video we're going to talk about Torricelli's theorem. We can use Bernoulli's principle to find the speed of a fluid coming out of a spigot of an open tank. This is called Torricelli's theorem. So basically we have a height difference between the top and the bottom. At the bottom we have a speed of a fluid of v1. At the top the fluid is not moving. So here, if we look at our kinematics equations, the speed is equal to the square root of 2g times the height difference. I'm sorry, the difference in elevation. A container of water has a spigot at its bottom. What happens to the water speed out of the spigot as the container empties? Does it A, decrease, B, increase, or C, stay the same? Hopefully you chose that it decreases. As you decrease the height of the water column above it, as you can see here, you're going to decrease the speed. A container holds water at a depth of 5 meters. There's a hole in the bottom of the container. At what speed will the water flow out of the hole? Go ahead and pause the video to solve for this problem. Okay, so let's take a look at the solution. Using our kinematic equation for the speed, we end up with 9.9 meters per second. Let's go ahead and summarize all the equations we learned in this unit. The density is equal to the mass per unit volume. We know the specific gravity is the ratio of the density of the object with the density of water. Pressure was defined as the force per unit area. We know that the pressure in fluids is rho GH. We also know the buoyant force is equal to the weight of the fluid displaced. Remember that we find the weight by taking the volume of the fluid times the density of the fluid, and that's how we get the mass of the fluid. Our continuity equation tells us that rho 1 A1 V1 is equal to rho 2 A2 V2, and Bernoulli's principle tells us that pressure plus 1/2 rho V squared plus rho GH must equal a constant.